Continuing on with the electronics, I just thought I'd show you the ramps board. I've removed it. One of the reasons why is that if you have your own machine shop, you can do changes quite easily and just fine tuning. These are the standoffs that I've applied to mount the board on, which I've mentioned to you before, but I have moved them 15 millimeters further forward. Part of that reason was trying to get it closer to the cabling, which we know is short. This is the mount for the fan. On the board itself, there's 4 holes, but only 3 can fit a screw in. So hence, there are 3 threaded ones. But this particular one is a stud. I cut off an nylon screw and screwed in it, so it's the same as those, but it's got it in. The reason why that is, assembling the board onto the master plate, normally it's difficult to try to line holes up and slipping, but if you just have the stud, just quite simple method to drop it on, and there it is aligned, no problems. So for the cost of less than a cent, you can add it to your board. But also I just wanted to show you the screws. These are the screws in the kit, and that's how far they stick out, which is enough for the nylon standoffs. But when you fit the LCD smart board, this one here, there is a hole in there for the screw. But unfortunately the head of the, unless you've got a real long screw, the head doesn't fit. So what a good idea is to use the same size screws, put them onto the ramps board and the Arduino board, the Mega board, before you put on this motherboard up the top. Then you can simply then just lower it down as before. I use this type of screwdriver. It's got the magnetic bit. You have different bits and they all fit in. But with the old fashioned type jeweler's screwdriver, they used to call them, you know, with the finger, that's wide enough or small enough to actually fit through the hole to get to the screw. So if you use this, it won't work. So if you've got a thin screwdriver, it will. So then it's just a matter of putting it on. And if you've watched any of my videos before, there's a trick in screws, bolts, that sort of thing. You turn them backwards and then you'll hear a little dop, and that's where the thread has dropped down into the other thread, and that means your threads are then aligned and you won't get any double threading, strip threads, that sort of thing. The other benefit, as here's a click, is that with only three supports, this will be sitting in the air. So it'll only be clamped on 3 sides, and pushing things in can bend it and all that sort of stuff. So it gives extra support, it's tight, that's how much airspace you get underneath. I also shifted the fan up a little bit further, shifted them 15 mil, and I shifted that 23, so an extra 8 mil. And this is a fan, got a little piece of plastic tube just in there. It's a 4 mil hole, but I'm using a 3 mil screw. Cabling goes through that side, and I shifted it so like out a bit and up a bit, so as it could be tilted a bit more to avoid the reset button, which is blocking the flow, and to angle it across. So that's how you can easily fit your electronics board, come in as one group, one assembly, or like I said before, once it's screwed to the power supply, it will just be the 3 screws to hold it on and take it off. So that's how easy it is. Some of these ramp boards have more text printed on, silk screen on it, than this one. So there's some that tell you what the connections are and some that don't. And that leads us to the stepper drivers. On the bottom of the stepper drivers, this photo will show you, it has got some description of the pins and they're labelled quite well. On other boards where your stepper driver goes, is also labelled, so you can look underneath and find out. This has no labelling. So the easiest way, looking at the board, since the writing is this way, you can read it. This is the left hand part of the board, this is the right hand part of the board, this is the top of the board, this is the bottom of the board. Visually for us. With your little stepper driver, and if you're using electronics, you can buy an anti-static wrist attachment that goes either, say, some have a lead, the dollar ones have a lead that you connect to your tap. This is supposed to have resistors in it and you don't need it, so you can fit on that. This is about $3 just to protect these small electronics. But on there you'll see a little trim pot. That trim pot is the right hand side. So when you store it, there's the top, there's the left, there's the right, there's a trim pot. The position of the drivers are there, there and up the top left. Now you can put your heatsink just by peeling it off and sticking it on, but you see some people have done it and they're all a bit dodgy. I plan to put mine on a certain way, and that way is with the fan blowing the air up. If I had this with the ribs pointing up or pointing down, this way, that way, it wouldn't allow any airflow. So I sort of looked at it and I said, yeah, it'll come up here, you'll hit a bit of this, bounce back, and I want the airflow to travel this way. So when I put these on, I'll have them all lined up to allow the air to flow across. Every little bit helps. Try to keep it away from the row of pins so it doesn't touch those and short those pins across each other, and try not to have it sitting on top of any other, hitting any other type of small components. It fits on that little chip there, little black one, so you just peel it off and stick it on. So I'll do that and then I'll get back to you and just show you with the LCD.